Your computer is fast, but for some problems, it's still too slow. It would take today's fastest supercomputers thousands of years to solve things a quantum computer might handle much faster. This isn't just about speed. It's about the potential to transform how we secure our data, protect our planet, and even how we treat diseases. Every device you use thinks in bits. Imagine billions of tiny phosphor green switches that can only be 0 or 1, off or on. Because they can only be one thing at a time, normal computers have to solve problems step by step in a straight line. Quantum computers use something very different, called qubits. Unlike bits, qubits can exist in a combination of both 0 and 1 states at the same time. This is called superposition. But how is that possible? Stay with me, because in the quantum world, probabilities, not certainties, define reality. Imagine a coin spinning on a table. While it's spinning, it's not just heads or tails, it's a blurred combination of both. Only when the coin stops, or when we measure a qubit, does it choose a single state. Until then, it's a cloud of possibilities. While a normal computer tries one path at a time through a maze, a quantum computer uses its wave-like nature to explore many paths in parallel. Through a process called interference, the computer strengthens the right path and cancels out the wrong ones, finding solutions for specific, complex problems. This quantum advantage doesn't apply to everything, but for things like chemistry and cryptography, it's a total game changer. And then there's entanglement. When two qubits become entangled, they behave as a single system even if they are miles apart. If you change one, the other reacts instantly. We can't use this to send text messages faster than light, but it creates strong correlations between particles. Imagine a doctor using this technology to dramatically reduce the time needed to discover new treatments for rare diseases. By simulating how molecules fold in high-definition light, we could discover breakthroughs much faster than years of lab work. But here's the surprising part. Quantum computers don't always win. For many daily tasks, your normal computer is still king. Where they do win is predicting global weather patterns with amazing accuracy and creating much more secure encryption methods. But these machines are incredibly fragile. To work, they must be kept close to absolute zero. That's minus 273 degrees Celsius. That's colder than the deepest parts of outer space. It's one of the most difficult engineering challenges humans have ever faced. Think of it like this. A normal computer is like trying keys one by one to unlock a door. A quantum computer explores the very shape of the lock. It finds the right key faster because it thinks differently, not just faster. This is the true magic of quantum power. This technology is still in its early days, but its potential to significantly impact our future is one of the most fascinating ideas in science. Some interpretations of quantum physics suggest the universe itself might exist in multiple states until someone looks at it. What does that mean for our reality? If you're asking these questions, you're already thinking like a scientist. You've got this. Follow Learn with Adeesha. Let's explore the universe together, one discovery at a time. See you in the next one.